Data pre-processing overview. What is data pre-processing? Data pre-processing in machine learning is a crucial step that helps enhance the quality of data to promote the extraction of meaningful insights from the data. Data pre-processing in machine learning refers to the technique of preparing, cleaning, and organizing the raw data to make it suitable for a building and training machine learning models. In simple words, data pre-processing in machine learning is a data mining technique that transforms raw data into an understandable and readable format. Why data pre-processing in machine learning? When it comes to creating a machine learning model, data pre-processing is the first step marking the initiation of the process. Typically, real-world data is incomplete, inconsistent, inaccurate, contains errors or outliers, and often lacks specific attribute values, trends. This is where data pre-processing enters the scenario. It helps to clean, format, and organize the raw data, thereby making it ready to go for machine learning models. Let's explore various steps of data pre-processing in machine learning. Steps in data pre-processing in machine learning. There are 6 significant steps in data pre-processing in machine learning. Step 1. Import the libraries. Step 2. Import the dataset. Step 3. Check out the missing values. Step 4. See the categorical values. Step 5. Splitting the data set into training and test set. Step 6. Feature scaling. 1. Acquire the dataset. Acquiring the dataset is the first step in data pre-processing in machine learning. To build and develop machine learning models, you must first acquire the relevant dataset. This dataset will be comprised of data gathered from multiple and disparate sources which are then combined in a proper format to form a dataset. Dataset formats differ according to use cases. For instance, a business dataset will be entirely different from a medical dataset. While a business dataset will contain relevant industry and business data, a medical dataset will include healthcare-related data. 2. Import all the crucial libraries. Since Python is the most extensively used, and also the most preferred library by data scientists around the world, we'll show you how to import Python libraries for data pre-processing in machine learning. Read more about Python libraries for data science here. The predefined Python libraries can perform specific data pre-processing jobs. Importing all the crucial libraries is the second step in data pre-processing in machine learning. The 3 core Python libraries used for this data pre-processing in machine learning are NumPy. NumPy is the fundamental package for scientific calculation in Python. Hence, it is used for inserting any type of mathematical operation in the code. Using NumPy, you can also add large multidimensional arrays and matrices in your code. Pandas. Pandas is an excellent open-source Python library for data manipulation and analysis. It is extensively used for importing and managing the datasets. It packs in high performance, easy-to-use data structures and data analysis tools for Python. Matplotlib. Matplotlib is a Python 2D plotting library that is used to plot any type of charts in Python. It can deliver publication quality figures in numerous hard copy formats and interactive environments across platforms, Ipython shells, Jupyter Notebook, web application servers, etc. 3. Import the dataset. In this step, you need to import the dataset S that you have gathered for the ML project at hand. Importing the dataset is one of the important steps in data pre-processing in machine learning. Four. Identifying and handling the missing values. In data pre-processing, it is pivotal to identify and correctly handle the missing values. Failing to do this, you might draw inaccurate and faulty conclusions and inferences from the data. Needless to say, this will hamper your ML project. Basically, there are 2 ways to handle missing data. 1. Deleting a particular row. In this method, you remove a specific row that has a null value for a feature or a particular column, where more than 75% of the values are missing. However, this method is not 100% efficient, and it is recommended that you use it only when the dataset has adequate samples. You must ensure that, after deleting the data, there remains no addition of bias. 2. Calculating the mean. This method is useful for features having numeric data like age, salary, year, etc. Here, you can calculate the mean, median, or mode of a particular feature or column or row that contains a missing value, and replace the result for the missing value. This method can add variance to the dataset, and any loss of data can be efficiently negated. Hence, it yields better results, compared to the first method, omission of rows, columns. Another way of approximation is through the deviation of neighboring values. However, this works best for linear data. Five. Encoding the categorical data. Categorical data refers to the information that has specific categories within the dataset. In the dataset cited above, there are two categorical variables, country and purchased. Machine learning models are primarily based on mathematical equations. Thus, you can intuitively understand that keeping the categorical data in the equation will cause certain issues, since you would only need numbers in the equations. 6. Splitting the dataset. Splitting the dataset is the next step in data preprocessing in machine learning. Every dataset for machine learning model must be split into two separate sets, training set and test set. Training set denotes the subset of a dataset that is used for training the machine learning model. Here, you are already aware of the output. A test set, on the other hand, is the subset of the dataset that is used for testing the machine learning model. The ML model uses the test set to predict outcomes. Usually, the dataset is split into 70-30 ratio or 80-20 ratio. This means that you either take 70% or 80% of the data for training the model, while leaving out the rest 30% or 20%. The splitting process varies according to the shape and size of the dataset in question. 7. Feature scaling. Feature scaling marks the end of the data preprocessing in machine learning. It is a method to standardize the independent variables of a dataset within a specific range. In other words, feature scaling limits the range of variables so that you can compare them on common grounds.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.